All right, well, let me introduce Natalia Ruiz, who is another person I've been working with for a while. Natalia is here at the University of Texas and working with the Center for Transportation Research. And she has been doing work both simulated and data-driven for improving what we consider sort of terrible traffic situation in Austin and across the state, and is going to be presenting to us about the notion of basically sharing transportation data across a wider array of folks, I guess, to improve research and outcomes. So is that about right, Natalia?
That sounds great.
Okay. Well, okay. Go ahead and kick it off. And I will note that Jen was in last month, so some of us have heard what's going on at the city. So it's sort of a back-to-back presentations on this stuff.
Okay, sounds good. So, well, thank you everyone, and thanks for the opportunity. So my first slide said something about data rodeo, which is data analytics environment. But this talk is not going to be about any specific platform, because actually we don't have one yet, but more of our path to get there and our findings while trying to do that, to establish a platform or an environment to support data-centric transportation research, which is ultimately our goal. So to provide a bit of context, here within CTR, I lead a small group of researchers that work on network modeling. And for those not in transportation, what network modeling means is there's a variety of models that agencies use to understand how traffic responds to different types of changes. They could be changes to technology, to the technology used, for example, for traffic signals, changes to the infrastructure itself, or changes to the way people travel through incentives. For example, if you want to have people traveling earlier during the day or later during the day, how would that look like when you implement it in the long term? And they use a variety of models. The models used in practice are often commercial software packages that are based on some theoretical principles but are quite dated. Academia is moving faster, but there is a slow process to go from models that are done in academia to models that are used every day to support decision making. And we were born with the idea of helping agencies get a taste for these new models, how they could be better, and in a way create a demand maybe for new commercial software products that can satisfy new needs, because things are moving quite fast in the industry. So one of the challenges with using these models, that what we call advanced transportation models, is that they require more computational resources, and they take more data as inputs, and they produce a lot of high resolution in terms of space and time definition of outputs. So one of our first ventures into trying to handle large data sets was actually trying to find a way in which we could better visualize and understand the model outputs and convey them to decision makers. And so we had a joint effort here with the Texas Advanced Computing Center, and we developed a tool to visualize model outputs that is kind of agnostic to which modeling tool you use. We were using actually an in-house developed model tool, and that was for us a life changer, because it helped us look at model results in ways that we were not able to do before, and actually to convey model results in a much easier way that helped others understand why these models are different. So that was really exciting, and for us it opened a lot of doors, but the problem of getting the data to fit the models was still there. And so part of the issue with transportation data is that we usually try to solve problems in a geographic area where there are several jurisdictions that overlap. So traffic signal data may live with the city of Austin or with the Texas Department of Transportation, and finding that data and getting it together and formatting in the right way for it to be ingested by the model is usually a challenge. So we came up with this concept of the data rodeo, which was, well, how about we talk to all the transportation agencies, we convince them to share their data, and then we create this wonderful environment that will let us do all these things that are in this slide, which is basically awesome. And then we were thinking something along the lines of what exists with Cyberse, or this other effort, Design Safe, that's more in the engineering area. So create an environment that facilitates data-centric research, and also on top of that, make it also easier for agencies to use such environments to share their own data. Now, this was sort of a top-down approach. We came up with this idea about 3 years ago, and over time we realized that there was not enough momentum to actually fund this effort from the top down for a number of reasons, some of which are institutional. Agencies usually have their own policies for data sharing. They're not necessarily comfortable sharing their data. They have their own challenges in managing their own data. And also they have their own initiatives for data sharing, so they often find it hard to fund yet another product that's going to be just one more thing they have to think about when they think about managing their data. And something else is also that even though we all have this feeling that data is going to be super helpful in transportation and help us have systems that are much more efficient and work better, there is really not a clear path between I have this extra data and my system is going to be this much better. So there is this concept that we know it should help, and there are certain applications where we can see it helping, but it's hard to sometimes for agencies to justify what's going to be the return of investment of making a huge effort in terms of data sharing and gathering. So what we decided to do was to take more of a bottoms-up approach, in which we started small with a more stakeholder engagement. We had a couple of hackathons that were very successful, generation of static data sets, and starting with prototype data applications with the idea of demonstrating the value of data or potential value of data, understanding what the critical workflows are, promoting this idea of data sharing, and also trying to better understand what the actual challenges are, which may not be technical. There are some technical challenges in some cases, but a lot of them are institutional. So my next slides are about some of these prototypes that we've been working on. For example, for the city of Austin, what we did is we took data from the traffic monitoring cameras, and we've been working also with the Texas Advanced Computing Center in developing some methodologies that help us analyze this data systematically. So there are a lot of commercial products now that actually use video data to compute traffic metrics, but they require installing new hardware. It's usually pricey, and they usually just do one thing. So what we were thinking is the city already has an extensive network of traffic cameras. Is there anything that we can do to use those cameras in a way that's more, so right now they are just used manually to do traffic operations. So when there's an incident, to see what's happening, to detect problems or unusual traffic conditions. So we were thinking, can we use them in a more systematic way to do either data collection or some type of long-term monitoring? So we worked on this prototype that ultimately what it's doing, it's using some existing libraries to recognize objects in the video. And one cool thing that we're doing is a lot of the existing products just work in real time. So the idea is that they're used for what we call traffic operations, which is to detect an incident or to count traffic, turning movements in real time to adjust signal timing, for example. But what we are trying to do is look at larger data sets and maybe be able to analyze changes in patterns, movement patterns over time. And so our first prototype had to do the vehicular traffic, but then we also are looking now into pedestrian traffic. And the pictures on the top have hotspots. So these are locations where we see many pedestrians or where pedestrians spend a lot of time. And then on the bottom slice, we have the trajectories. So the reason why this is interesting is because you can see a lot of trajectories moving across the roadways at locations where there are no crosswalks whatsoever. And that happens a lot in Texas because not all the roadways are very pedestrian friendly. So sometimes you have to walk half a mile to cross the street, and people just don't, and they cross wherever it's more convenient, and that can cause safety issues. And so the city has been trying to see, can we use this technology to identify problem areas, and also if there is some type of measure that's taken to improve conditions, can we look at data over time and see if things are better? And usually these things are evaluated manually, so people either go and observe or take videos for a small amount of time and then look at it manually. So having a tool such as this one could help them be more efficient in evaluating the impact of their techniques. Something else that we've been doing is we've been using data from vendors, and this is travel time data along corridors and roadways in the city, and we are trying to see if they can use that data to be more efficient in the way that they decide which traffic signals they have to retime. So it's common practice that if an agency operates, let's say, 1,000 signals, they're going to retime or improve the timing plans on a portion of them every year, because they usually don't have the resources to retime all of them. And how that portion is selected, often the simplest way is just to make sure that everything gets retimed over a reasonable period of time. So maybe everything needs to be retimed every 3 years or something like that. But now there is more data available, so we were trying to help them come up with a process that will help them prioritize which, in this case, third of the traffic signals should be retimed and what would be best would benefit a larger portion of the population. And this has been pretty successful. The data is vendor data, so it's not data that can be made publicly available because the city is paying for that. But this data is becoming more common from different vendors, and it's a pretty valuable source of data. And so this is just showing how we can look at a corridor, which is typically an arterial street, and we can see how speed has been changing over time to try to see if that's the right corridor to retime. And we are developing a methodology based on this. We've also used multiple data sources from the Texas Department of Transportation to try to develop methodologies to understand what's the cost of a lane closure. So when we close a lane, either for construction, so a planned closure, or we close a lane because there is an incident and it needs to be cleared up. There is delays. Those delays have a cost to the users. There are simple ways of estimating those costs, but as more and more data becomes available, we can develop more refined techniques that let us better understand what impact how effective are our methodologies to inform the public and to avoid excessive delays when implemented. So we've been working with the Texas Department of Transportation in using data from multiple sources. Some of them are displayed in this image. And here the challenge is usually data aggregation and how do we get this data from all these different types of sensors and how do we get our hands on that on time. And we've been working on a number of other smaller data projects, looking at ride-hailing data, multimodal level of service, so data from transit in addition to data from regular vehicles. And we've been even working with the city on a project to develop Wi-Fi sensors. So these are sensors that we put in the infrastructure on poles, and they capture the MAC ID through the Wi-Fi of Wi-Fi-enabled devices. And then by looking at the same ID at two different locations, we can understand movement patterns and also travel times. There are some caveats there with personal identifiable information, but there are ways to get around that. And there are such sensors that are commercially available, but they are typically pricey. So we've been playing with just developing simple ones using Raspberry Pis and seeing how do they work. And so we had kind of like a hackathon around that as well. And so all in all, through this process, one thing that we've learned is that these collaborations between the university that may support like innovative thinking, vendors that are collecting data and they have their own ideas, but they want to see how they can, in a way, make that data being used by agencies, and also agencies that have the real needs and problems that need to be solved are very helpful. And we find it's extremely important to really understand the value of data. It's often the case that the data is being collected for no specific purpose. And so that is challenging when we get a project that has to do with analyzing the data, because we don't always have guidance in terms of what is it that we want to get out of this data. So these relationships help understand that. And then so that we can identify what's the best approach to really accelerate innovation through collaboration. There are a number of products. Sometimes I feel that agencies are overwhelmed, but the availability of data platforms, data integration software, data collection. And so understanding what the landscape looks like and what would be a good role for the university and for research, I think is critical, because the products are out there, the data is being collected, and we need to provide value on top of that, not just go on our way and without really understanding what the needs are. Sorry? And then we feel that this collaboration also helps promote the sharing of data, and we've seen an increase in the so agencies are more interested, especially the city of Austin is very interested in opening their own data, and that has been really great for us. And then we find that working with real data, both in education and research, has been very valuable for students. They are starting to use more of this data in class projects. They work with us in projects, and then they're interested in doing research using that data. So that for us has been great. In terms of actually developing this environment for data integration and tools, we're still trying to find what's the right way to do it that will really get traction and that won't overlap with other efforts that already exist at the agency level. So this is what I have. I don't know how I did with time. I apologize if I spoke too much.
No, I think it went pretty well. A little long, but that's good.
Sorry about that.
Well, I was just going to comment that it seems that it's the usual problem of people valuing data over results in a lot of this. Yeah, I know it's difficult to get the information across to different agencies and from different agencies. Along those lines, have you really been seeing much of a change in that just in the city of Austin, or are other agencies starting to understand the value of pooling efforts and bringing things together? And if so, what are the next sort of steps you see to pushing that forward?
So, I mean, the city of Austin definitely has a great attitude towards data, and from their point of view, the more data they can share, the better, which makes our life easier because they are interested in pushing their data out. So in terms of integrating data, that makes it very easy. I also seen a little bit of a change in the industry in that it used to be the case before that data was collected by specific hardware, and then there was just one single software product that you could use to look at the data. And I see things moving more in the direction where data is in the cloud, and there are APIs to access the data. So that makes everyone's lives easier. And I think for other agencies, it's always scary to share data. They're worried about what people will do with the data. They're worried about complaints about the data quality. So it's kind of slow. I haven't seen any drastic change in other agencies, but definitely more interest in collaborating. So I've seen the city talking more with the Texas Department of Transportation, and I think some of these projects which actually show some outcome out of the data analysis, so we're using data to solve this problem, are appealing to agencies. And sometimes if we do it with the data from one agency, some other agency gets interested, and maybe they see the benefit of pulling data together to get more out of it. So we are still going from the bottom up and trying to see what gets more traction